Okay, so 2D and 3D shapes. Today, we're just going to look at naming them. Tomorrow, we're going to actually start finding the volume. Today, I just want to make sure you get the names down. Okay, because if I tell you to find the volume and there's no picture, but I give you a name, you need to know what it means. Okay, so a 3D shape is technically called a polyhedron. A polyhedron is a solid that is bound by polygons enclosed in a single region of space, aka a 3D shape, is a polyhedron. The faces of a polyhedron are polygons. That's where it kind of gets its name from. So the faces is basically any side. Okay, polyhedrons have all straight lines. So like a pyramid is a polyhedron, a prism, we'll get there. The edge of a polyhedron is a line segment formed by the intersection of two faces. So any side is called a face. So like this thing, you can't see it, is a face. An edge is just like the line that connects two of the faces. That's an edge. A vertex is a point where three or more edges meet. So this would be a vertex. A base is the polygon that's used to name the polyhedron. A base is just a special face. Okay, so everything's a face, but a base is a special face. Any side that you have is a face, but our bases are special. Okay, that's how we name it. Okay, so any 3D shape. So this is a polyhedron. Has all straight lines. So when we classify a solid, if it's a polyhedron, there's basically two categories. It can either be a pyramid or it can be a prism. To name a pyramid or a prism, we use the shape of the base and then the word pyramid and then the word prism. So when we're naming polyhedron, we use two words. So the base of a pyramid is a polygon. So this pyramid here is a square pyramid. Because the base is a polygon, it's a square, and then it's a pyramid. A pyramid all leads up to one spot. The other faces here are triangles. Okay, just make a note, the base is not always the bottom. If I showed you this picture here, see, the bases are these two things. That's not necessarily the bottom. People always think base, bottom, but that's not necessarily true. This figure here, the bases are the pentagons. Do you see how there's only two pentagons that are the same? We call this a pentagonal prism. Okay, two bases of a prism are congruent polygons in parallel planes. The other faces are rectangles. So you have to know the difference between a pyramid and a prism. A prism has two of the same base and rectangles in between. So this is a prism. This is a triangular prism. A pyramid has one base and everything leads to one point. So this is a triangular pyramid. Square pyramid. Okay. Not a polyhedron are these things because they have not straight lines. Do you know what this thing's called? A cone. Like an upside down ice cream cone. What is this thing called? It's not a ball, it's a sphere. What did I say this was called? There you go. So we take a day just to name the shapes because that way when I talk about things, you kind of know what I mean. Okay, that's the hardest part because you got to be able to figure out what you're trying to find the volume of. So tell whether the solid is a polyhedron. If it is, name it. Classify the different faces and list how many there are. So this thing, first of all, is it a polyhedron? Does it have all straight lines? So we can say polyhedron. Now we got to name it. What's the base? What's the 2D shape that's the only one there? This, I hate saying bottom, but this part is a hexagon, right? So we call this a hexagonal. Is it a pyramid or a prism? Hexagonal pyramid. Okay, so you always, when you name a polyhedron, want 2 words. What's the shape of the base, and is it a prism or a pyramid? And we really only get up to hexagonal stuff. We do triangles, rectangles, squares, pentagons, hexagons. We don't really go past that. Maybe you'll see a decagon, but don't worry about the other ones. Now, how many faces are there? Remember, everything's a face, that's a side. There's 1, 2, 3, 4, 5, 6, 7 faces. 1 base and then 6 triangles. Is this next one a polyhedron? Does it have all straight lines? So it's a polyhedron. What do you think the name of it will be? The bases are actually these, this side here, and this side here. Those are the bases. They're the only 2 sides that look alike. So this is a rectangular prism. And I promise I won't be too mad about the spelling. So how many faces total are there? How many sides are there? Yes. There's 6 faces. 6 sides. It's like a box. Is this a polyhedron? Does it have all straight lines? No. This is actually 2 things put together. We'll get to that later. Is this one a polyhedron? Does it have all straight lines? So you have to look at the base. The base is this side here and this side in the back. Okay, see how the bases aren't necessarily the bottom? So what do you think you'd call that? What? Is it a prism or a pyramid? Does it lead up to one point, or is it like an accordion? If it's an accordion, it's a prism. If it leads up to one point, it's a pyramid. Wake up, everybody. It's a prism. What kind? How many sides does this side have? Does this shape have? 5. What's a 5-sided shape called? Good. So it's a pentagonal prism. How many faces does it have? 1, 2, 3, 4, 5, 6, 7. And you can just count the number of faces. Is this a polyhedron? Does it have all straight lines? No. We'll just say no. Last one. Is this a polyhedron? What do you think you're going to call that? What kind of pyramid? No. Yeah, the base is this bottom, Aaron. Is this rectangle. So we call it a rectangular pyramid. Okay, you can't just say prism or pyramid. You got to give me 2 words. So how many faces does it have? 1, 2, 3, 4, 5. So besides that, with 2D and 3D shapes, there's a way that they kind of relate. Is with a cross section. A cross section is the intersection of a plane and a solid. It should make a 2D shape. So like a circle, a triangle, a rectangle, a pentagon, a hexagon. Something we've learned. So this pyramid, if I cut the top off, it makes a triangle. That's what the cross section is. Okay, you guys see, you'll see cross sections all the time. I'm thinking science. When you cut something and you take a little bit out. Have you ever had that canned cranberry sauce from Thanksgiving, and when you take it out, it still looks like the can? That is a cross section what you're eating. So you're looking for a 2D shape that's cut from a 3D shape. So describe, if you're a visual learner, this should be real easy. If you're not, it may take you a minute to visually see what's being made. Okay, unfortunately that's hard for me to teach. So describe the cross-section formed by the intersection of the plane and the solid. So if I take a sphere and I cut it, what is this cross-section? What 2D shape? Circle. If I take this, oh, you can see. If I take this pyramid and I cut it, what does it make? What's that little guy? A pentagon. What about this cylinder? If I cut it, what did it make? What about this guy? This prism. When I cut it, what did it make? A pentagon again. So what do you notice about the shape of the cross section when it's parallel to the base? In both of these instances, my cross section was parallel to the base. This was a pentagonal pyramid. This was a pentagonal prism. The cross sections are both pentagons. So if you cut a 3D shape parallel to the base, the cross section and the base are the same figure. Well, 2D shape. Okay. Now, this one takes some visualization. We're going to take a 2D shape and spin it. Identify the three-dimensional object formed by rotating the two-dimensional object about the line. So if I took this, this is a rectangle on the y-axis, and I spin it around, and I spin it, and I spin it, and I spin it, and I spin it, and I spin it. What 3D shape do you think I'll make if I keep spinning super fast? If I went faster than this. It's got to be a 3D shape. Think about it. I'm spinning this round and around and around and around. Jack, what'd you say? Yes, this is a really bad drawing. But you create a cylinder. If I were to spin really, 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 really fast. You can't see that, but I create a cylinder. If you spun that around the y-axis over and over and over again, you'd create a cylinder. What if I took a triangle and I spun it around the x-axis? So what if I take a triangle, but instead of spinning it around the y-axis, I'm going to spin it around the x-axis, this way. So I'm going to keep spinning and spinning and spinning and spinning. What would it make? A cone. Good. Because you're spinning it this way, and so you're almost creating a cone. Thank you. What do you think happens when you spin a circle around and around and around? When you spin a circle around and around and around? Yes, you get a sphere. Okay, the reason we kind of talk about this is in calculus you do that, and then you got to find all the craziness of it. Okay, so example 4 is kind of just a recap. Name the polyhedron and classify and list the faces. I'm also going to list the edges and the vertices, because that's what part of your homework's going to be, is to list the faces, the edges, and the vertices. There is a formula called Euler's method that will help you with the faces, the edges, and the vertices, because counting the vertices can get annoying. And the formula is the faces plus the vertices equals the edges plus 2. Because on your homework, it's going to ask you to count all this stuff. Okay, so we're going to name it, and then we're going to do faces, edges, vertices. And to double check our answer, we're going to use this formula. So what do you think this figure is called? Bless you. Is it a prism or a pyramid? It's a prism. What's the base? What's this guy and this guy? How many sides? 1, 2, 3, 4, 5, 6. What's a 6-sided figure called? This is a hexagonal prism. So let's count. First, let's count. The faces are the easiest. Count the faces first. So anything that's a side is a face. So 1, 2, 3, 4, 5, 6, 7, 8. Good. Now, you can either count edges or vertices. Personally, I do vertices. Vertices is like all the corners. So I just take my pencil and I just look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I just look, where do they all connect? There's 12 vertices. Now, if you want to count the edges, you can, or we can use this formula. If you want to count, you got to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So double check with your formula. 8 plus 12 should equal 18 plus 2. What's 8 plus 12? What's 18 plus 2? So there you go. Okay. Is it making sense? Next one's this guy. Is this a prism or a pyramid? Pyramid. The bottom is a 1, 2, 3, 4, 5-sided figure. Yeah, so this is a pentagonal pyramid. Pentagonal pyramid. So how many faces are there? Count the number of sides. 1, 2, 3, 4, 5, 6. I kind of wrong. Shoot. No, I didn't. Oh, I did that wrong. 6. Number of edges or vertices. Let's do vertices. 1, 2, 3, 4, 5, 6. Edges 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's where I count them. Then check with your formula. 6 plus 6 should equal 10 plus 2. What do both of those sides equal? Okay. Last one is kind of hard to see. Prism or pyramid? Prism. What's the base? It's a triangle. That's why I said the base is not necessarily the bottom. These are the bases. Okay, in a prism, you're looking for the two things that look the same. So this is a triangular prism. So the faces, there's 1, 2, 3, 4, 5 sides. Vertices, 1, 2, 3, 4, 5, 6. Edges, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you can check. 5 plus 6 equals 9 plus 2. Okay, they both equal 11. Okay, question.